Hello students, welcome to Siddapur Mathematics Academy. So in today's class, I am starting with differentiation. I know that all of the students are waiting for this differentiation. So here in the today's class, first I am giving you the basics. See, even though you are studied in the first year, that is the class 11. In the class 11th, what you are studied in the class 11th, we are studied by using first principle. So after development of techniques, we are using the formulas directly and we are going to differentiate the terms. So what is the meaning of differentiation? In short, leave that. See here, if you are getting a curd, curd is from where you are getting from using the milk, you will get the curd. So curd is called the derivative from the milk. It is a derivative from the milk. That means we are dividing the work into into small units. So we are dividing the work into small units. In integration, what we are doing? We are collecting all the small units into one work. So it is totally reverse of that. So those who are not studied properly in the first year also, don't worry. I will explain each and everything this year and I will make you perfect. See the video till end and give the comments. So share with your friends. So in the first year, as you know that we are studied about a first principle. And after development of, now in the second year, directly we are using the differentiation formulas. And the question will be, maximum time we are using the function is in the form of x. So what you are using then? Differentiate the following with respect to x or find the derivative. Here we are differentiating the function. The functions are algebraic functions, logarithmic functions, exponential functions, trigonometric functions, like that. So if you want a first principle, see the video of first year, that is a class 11th videos. Here we don't have the first principle, directly using the formula. So here, before going to any examples, as I told you, maximum we are using in the form of y. Y is equal to, everything is in the form of x. First I am giving you important formulas, standard formulas. Take a paper and pen. I will explain very slowly and go on writing that formulas along with me. And see, y is equal to f of x. F of x is a function. It may be algebraic, trigonometric, exponential, logarithmic, whatever. And if the question is find the derivative, when you are differentiating, see, it is in the form of, the function is expressed in the form of x, means what you are writing? Differentiating with respect to x. At that time, y will be written as dy upon dx. This is the first differentiation. Differentiating once, first derivative. And f of x will be written as f dash of x. That means dy upon dx is nothing but f dash of x. Sometimes it is denoted by capital D into y, or y1, or y dash, or y1. Like this we are denoting the first derivative. Understood? Now write down the formulas here. Here differentiation, when you are reading, it is differentiation of x raised to n. It is n into x to the power n minus 1. Here x is a variable, as you know that. N is a number. It may be positive, negative, fraction, whatever. N is a number. And when I am explaining, I will explain each and every. First I want to give you the formula list. Second one. Actually this second one I am giving you after writing the example. But leave some place. So after explaining the example, for examples here in place of n, what we have, root x will be written as x raised to half. Correct or not? Then what is its differentiation? Its differentiation, in the place of n we have a 1 by 2. So in place of x we have 1 by 2. Apply that formula. N into, that means 1 by 2 into x to the power 1 by 2 minus 1. That is 1 by 2 x to the power 1 by 2 minus 1. Take the LCM and solve. This will be minus half. Correct or what? That is 1 by 2 x to the power, minus comes in the denominator. That is nothing but 1 by 2 root x. That means differentiation of root x will be 1 by 2 root x. This we are using when we are solving the example directly as a formula. 1 by 2 root x. Third one. Differentiation of 1 by x. This also I will explain. See, differentiation of 1 by x. This will be written as differentiation of x to the power minus 1. You are familiar with indices. When you write 1 by x in the numerator, it is x to the power minus 1. So in place of n, what we have? Minus 1. So it is minus 1 x to the power minus 2. Finally we got minus 1 upon x square. So differentiation of 1 by x is minus 1 by x square. Understood? Next, differentiation of e to the power x exponential, that is e raised to x. Next, differentiation of a to the power x. A is a number. It is a raised to x into log a to the base e. Next, differentiation of log x to the base e, natural log. It is 1 by x. Understood? Make the list and write slowly along with me. Next, seventh one, differentiation of k. K means any constant. Any constant means you are differentiating with respect to x. It is a variable. The term without x. So in this chapter I am explaining. Suppose if you are differentiating with respect to x means the term without x. Understood? The remaining term we are treating as a constant. If y is a function of x means don't treat as a constant. Generally the numbers, alphabets we are treating other than x, a, b, c, d, we are treating as a constants. So differentiation of a constant is 0. Where k is constant. Suppose if you have like this, k into f of x, constant and f of x means we keep constant as it is and we have to differentiate f of x. Understood? Then differentiation of, I am giving you all trigonometry term. Differentiation of sin x. Already this we are studied in the last year class, that is first year by first principle. Differentiation of cos x is minus sin x. Differentiation of tan x will be secant square x. Differentiation of cot x minus cosecant square x. Differentiation of secant x will be secant x into tan x. Understood? Next. Differentiation of cosecant x will be minus cosecant x into cot x. Next, differentiation of u plus v. Not only for two terms, more than two terms also. If middle plus is there, you have to write differentiation of x plus differentiation of v, where u and v are functions of x. Similarly, not only for two terms, you can write in general u plus v plus w plus continuation. Whatever the terms, you can differentiate separately. Understood? Similarly, we can differentiate u minus v for subtraction also. Not only for two terms, in general also you can write. U minus, remember for everywhere u, v, w, they are the functions of x. because you are writing the differentiation with respect to x here. Next, differentiation of u into v, two terms, product of two terms, where u and v are functions of x. See, you keep u as it is, differentiation of v plus v as it is, differentiation of u. And even though it is not in the NCERT, but remember u, v, w, three terms are there. Keep two terms as it is, differentiate the third one. So here I kept uv as it is, differentiated w. Though before differentiation terms means we have to keep as it is. Now I will keep u and w as it is, differentiating v. So here we differentiated w, here we differentiated v, then we have to differentiate u. vw, differentiation of u. So it is not necessary like that. You can write u first, then v, then w. That is left with you. Because it is a addition, there will no change if you change their places. Then differentiation of u by v. It is very important. Remember, u by v, quotient rule. V as it is, that is denominator as it is, differentiation of numerator, minus u as it is, differentiation of v upon v square. Always the students get confusion here only. Make the correction. This is very, see, please note down that. It is very important. And don't think only 20 formulas are there. Again, so many formulas, inverse trigonometry. That I am giving when I start the exercise of that inverse trigonometry, differentiation of inverse trigonometric function. So that's why I am telling, leave some place for a formula. So these are the formulas. Have you listed this? Now I am moving with the very small things. First I want to make you a perfect in basics. Then only I will move to the NCERT, that is chain rule. Watch the video till end. So I will give you a guarantee you will be perfect in this differentiation. And if you are perfect in differentiation, integration easily we can do. Now we are moving to the small examples. First basics. As I told you, I will make perfect in all of basics. Then I will move to the NCERT. The question is, find the derivatives. Find the derivative of each of the following functions. Correct? So first question, 1 by x square. So when you are writing a solution, you can write, I will show you two methods presentation. One thing is you can write directly like this. Differentiation of 1 by x square will be written as differentiation of x goes up, x to the power minus 2. So which formula? Differentiation of x to the power n. It is n into x to the power n minus 1. What is in place of n? Minus 2, x to the power minus 2 minus 1. It is minus 2 into x to the power minus 3. So answer is minus 2 upon x to the power 3. And maximum students, they will ask the question, Miss, if you keep the answer here only, will you give the marks? Yes, we will give the marks. But here it is a negative, no? Make it a positive, only that much. And the second one. Suppose if I gave you a x. I will explain one more method. See, you can write this function as a y. Y is equal to x. This is direct differentiation. You can write in this way also. Now I am writing differentiating with respect to x. This will be written as dy upon dx. And here, what is the power of x? The power of x is not given, means is it 1 or what? So x to the power n. N means n into x to raised to n minus 1. In place of n we have 1. 1 into x to the power 1 minus 1. 1 into x to the power 0. Anything raised to 0 is 1. So your answer is 1. That means differentiation of. So what is y? Y is nothing but x. differentiation of x with respect to x with the same term, your answer will be 1. So write down this in the formula list. As I told you, I will use so many formulas in this. So write down, because in examples we will use directly. Next. 3 into x square. 3 into x square. As I told you, now in everywhere I am writing as a y. Let y is equal to 3x square. Differentiating with respect to x. So what you will get? Dy upon dx is equal to d upon dx 3x square. 3x square. In between the numbers, what is there? Multiplication. And 3 is a constant. Then what you will write? You will write 3 as it is. We have to differentiate x square. Understood? So here 3 as it is. X square is in the form of x to the power n. So what is x to the power n? 2 into x raised to 2 minus 1. N into x to the power n minus 1. Correct or what? And because of multiplication, we are multiplying this. And 2 minus 1 is 1. Correct or not? Next question. 1 upon... See. What you are doing here? I am writing y is equal to 1 upon like this. And in the numerator we don't have a x. In the numerator we don't have a x. That's why I am writing 1 by 3. Don't take 3 in the numerator. The number keep as it is. When you take x to the power 6 in the numerator, it becomes x to the power minus 6. See, these two examples are similar or what? Not same. Similar or what? Yes. Now, how you are writing? Now first we are writing differentiating with respect to x. LHS will be written as dy upon dx. Here I kept 1 by 3 constant. So it is 1 by 3 constant. That's why I wrote first differentiation of x to the power minus 6. It is 1 by 3 minus 6 x raised to minus 6 minus 1. Because of multiplication, if any cancellation is there, go for that cancellation. Next question. Suppose it is only 5. What you will write? Let y is equal to 5. See, with y, with 5 there is no x. And question is find the derivative. Of course it is with respect to x only. And 5 we are treating as a constant. Differentiating with respect to x. Dy upon dx. Differentiation of constant is what? If only constant, it is a 0. But constant with variable means this method. So only constant is 0. Next question. Question number 6. 3 upon 8 x raised to 12. So y is equal to 3 upon 8 x raised to 12. It will be written as 3 upon 8 is a constant. See like this. Differentiating with respect to x. Dy upon dx will be 4 2s are 8, 4 3s are 12. It is minus 9 by 2. Understood? Next question. See, See, x is already in the numerator. No need to change it. I know that now the students are happy because they are feeling it is very easy. dy upon dx, 3 by 4 constant, differentiation with respect to x. 3 by 4, 8 into x raised to 8 minus 1. 6 into x to the power. Correct or what? Yes. 4 upon cube root of x square. Still, y is equal to 4 upon cube root of x square. And you are familiar how to convert these surds into indices. It will be x raised to x square whole raised to 1 by 3. That is nothing but 4 upon x to the power 2 by 3. Differentiating with respect to x. Dy upon dx is equal to, here 4 is the, one more step is 4 into x to the power minus 2 by 3, because it is present in the denominator. I wrote in the numerator. 4 into differentiation of x to the power minus 2 by 3. Taking LCM and simplifying. See, so simple it is. Question number 9. Next. Minus 2 upon 3 into cube root of x. Here. Let y is equal to 3 into cube root of x. Remember, it is minus 2 by 3, x to the power 1 by 3. Take in the numerator. Simplify this. Minus 1 by 3 minus 3 minus 4 by 3. And I did the multiplication of these two. See, this is how we are solving. Yes. Y is equal to, have you remembered the conversion? X to the power minus 2 by 5. Directly I wrote the conversion only. Now differentiate. It is 5 by 2 minus 2 by 5. X to the power minus 2 by 5 minus 1. Here it is the multiplication. This is 5 by 2, this is 2 by 5. They get cancelled for what? Yes, it is minus x raised to minus 7 by 5. Next question. See, y is equal to, what is the conversion? 6 into x to the power 5 by 6. now directly I am writing. I kept 6 as it is. Now I am writing it because I wrote here differentiating with respect to x means without writing d upon dx directly I am writing like this. 5 by 6 x to the power 5 by 6 minus 1. Here and here get cancels because the multiplication. What is left? 5 into 5 by 6 minus 1 is minus 1 by 6. Correct or what? I know you are familiar with this subtraction all. So it is 5 upon x raised to 1 by 6. Next question. X raised to 4. So what you are writing? Y is equal to x to the power 4. Which formula? X to the power n. Differentiating with respect to x. Dy upon dx is now directly you can write 4 into x to the power 3. Directly you can write or what? Because 4 minus 1 is 3. No need to write that. Starting I wrote because I want to make you a perfect and I want to explain you the basics. Yes, without writing anything, can you solve this? Yes, tell me what is the answer? The answer is 3x square. Correct or what? Here only I gave the answer only. Just in the systematic way write down. Differentiation of x cube is n into x to the power n minus 1. That is 3 into x raised to 3 minus 1. That is 3x cube, 3x square. Next question. 14. What is x to the power 12? Yes. N into x to the power n minus 1. 12 into x to the power 12 minus 1 is 11. 12 into x to the power 11. Yes. Next question. 1 upon root x. Here. Let y is equal to 1 by root x. Root x, how you convert in the form of index? Raised to half. So it is 1 upon x raised to half. It is in the denominator. And in the numerator we don't have x. That's why I am taking this in the numerator. Minus 1 by 2. Differentiate this. Differentiate with respect to x. N into x to the power n minus 1. Correct or not? Next. 8 into x raised to 4. Differentiating with respect to x. 8 constant, 4 into x cube directly, 32 x cube. See if they are simple or what. That's why I am starting with the basics. If I directly move to the composite functions, we will not follow anything. A into x cube here. Let y is equal to ax cube. Differentiating with respect to x. See, a we are treating as a constant. A as it is. What is the differentiation of x cube? 3 into x to the power 3 minus 1. That is 2. If you want, you can make a small change and you can write like this. Same thing. This will be written as differentiating with respect to x. Minus 3 by 4 constant minus 3x to the power minus 3 minus 1. Because it is a negative I wrote here. And multiply this. It is 9 by 4 x to the power minus 4. This minus and this minus becomes plus. It is 9 by 4 x to the power 4. Next question number 19. 2 upon root x. See how you write. Let y is equal to 2 upon root x, and I kept 2 as it is. Root x, when you take in the numerator, it will be written as x to the power minus half. Correct or what? Because root is half. When we take in the numerator, it becomes minus half. Differentiating with respect to x. 2 as it is. This is n into x to the power n minus 1. This 2 and this 2 get cancelled. So this will be the answer. Correct or what? Question number 20. A upon x to the power n. How you write? A constant, x raised to minus n. Now differentiate that. Minus n. So if you want, you can write n. It both are negative. When you write it in the denominator, they become positive. So when I am explaining the basics, I will not give any homework. Don't worry about it. When I start the NCERT, I will give the homework. See, in between the terms what we have, in between the terms middle we have plus and minus. That means first what we have to do, we have to write the problem like this. Now differentiate with respect to x. T is dy upon dx. That means we have to differentiate this term separate, this term separate, this separate, this separate, middle plus and minus. So first I am doing is this one, 8 as it is. How to differentiate x raised to 4? 4x cube. If you are thorough, I will give one more direct line. Plus 7 as it is. It is 3x square minus 6 as it is. Differentiation of x square is 2x, because 2 into x to the power 2 minus 1. Now you can write, because second PUC students, addition, subtraction, these simple numbers are very easy. And in the formula list you wrote, what is the differentiation of x? Yes, differentiation of x is 1. So 4, differentiation of x is 1. And what about the differentiation of 7? Only number, that is a constant, it is 0. Watch it carefully and write it carefully. Now it will be written as 32x cube plus 21x square minus 12x plus 4. Next question. Ax cube plus 3bx square plus 3cx plus d. Yes, students, in the first step what we have to do? Let y is equal to ax cube plus 3b square plus 3cx plus d. Remember, other than this is anyhow, we are representing the function as a y. The other than x terms, the remaining term we are taking as a constant. Understood? Differentiating with respect to x. So dy upon dx is equal to a constant. What is the differentiation of x cube? 3x square. Yes, here what is the constant? 3b is the constant. Differentiation of x square is 2x. Correct or what? Next 3c constant, differentiation of x is 1 and differentiation of d will be 0. Final answer is 6bx plus 3c. Question number 23. 9 into x to the power 5 minus 4x cube plus 12. Let y is equal to differentiating with respect to x. dy upon dx. Keep 9 as it is. 5 into x raised to 5 minus 1 is 4. 3x square plus 0. Differentiation of 12 is 0. Understood? So this is how we are solving. Moving to the next question. Five into x to the power 4 plus 3x cube minus 7x square plus 9x. Let so this is x cube. I'm sorry. Differentiating with respect to x. Left side we are writing dy upon dx. Here, after writing like this, you multiplied or what? So directly, can you write this step? If you are perfect. So what is the differentiation of 5 into x to the power 4? Is it 20 into x cube or what? This goes one unit less and we are multiplying this. Then yes, come on, tell me what is 3x cube? 9x square minus 14x, and differentiation of x will be 1, that's why it is 9, and differentiation of 8 is 0. Let y is equal to x cube plus 4x square minus 5x plus 6. Differentiating with respect to x. Very simple it is. 3x square and it is 8x minus 5. Because the differentiation of x is 1 and plus 6. Differentiation of 6 is 0. Into x to the power 4 minus 4x cube plus 3x square minus x plus 7. Differentiating with respect to x. Yes, what is the differentiation of 2 into x to the power 4? 8x cube minus 12x square plus 6x minus 1. Correct or what? Yes. Next. Here, let y is equal to. See students, here we are familiar with this differentiation. Here just I did one small change. I kept 1 by 4 as it is. I took x in the numerator. Now differentiate. what is the differentiation of 2x square? 4x. Next, I kept minus 1 by 4. This I wrote in the bracket. Minus 3x to the power minus 3 minus 1 is minus 4. So this will be, this minus and minus becomes plus, and I took that x to the power minus 4 in the denominator. Differentiating with respect to x. Yes. What is the differentiation of x to the power 4? 4x cube plus a square I kept as it is. Differentiation of x square is 2x. Yes, what about the differentiation of b square? Is it 0 or what? Because with b square there is no x, so it is a constant. Your final answer is let y is equal to differentiate. They are in the form of x to the power n. N into x raised to n minus 1 plus in the bracket minus n x raised to minus n minus 1. Final answer is plus into minus is minus. Question number 30. A upon x plus b upon x square plus c upon x cube. See, first I will write the problem in systematic way. And open the formula list. In that formula list, see, a by x is nothing but a upon x will be written as a into 1 by x, correct or not? Out of these 4 terms, which formula you are familiar in the formula list which is given? Is the differentiation of 1 by x is familiar or what? That's why I am writing. Only this term I kept as it is because we are familiar with that formula. The remaining I wrote like this. Everything I write in the numerator. Differentiating with respect to x. A I kept as it is. Differentiation of 1 by x is minus 1 by x square plus b as it is plus c as it is it is minus a upon x square plus into minus a is minus b. It comes in the denominator. Minus 3 minus 1 is minus 4. I wrote in the denominator. It is 5. Correct or not? So I explained 30 questions in this class. In the next class again I will explain the basic simple examples only. After that, after we are perfecting the simple examples, I will move to the composite function or chain rule. So in the class I will explain 30. Please practice this.